Okay, so we're going back here. We're going to finish up number 2. Okay, guys. All right, we distribute the 4. You're going to get 2x plus 24 equals 6x minus 20. You with me? Distribute that 4, right? Now from here, it's just algebra solving for x. Move the 2x over, add the 20, and you're going to get 44 is equal to 4x. Divide both sides by 4, and x equals 11. Now, is that my answer? No, that's just x. It's asking for Pn. Well, I can plug it in to find the whole thing. Okay? If I plug it in right here, I don't have to use any fractions, right? Okay? So I plug it in there. 6 times 11 is 66. 66 minus 20 is 46. So the whole thing is 46. But that's not what the question's asking. It's asking for Pn, and Pn is half of the whole thing. Yes? So that means that Pn is equal to 23. Fantastic. All right. Now, number 3, I'm going to show you how to get rid of the fractions on this one. It's going to be kind of fun. Okay? All right. So it says B is the midpoint of AC. So let's draw our segment AC. And B is the midpoint. Is that okay right there? All right. We need to make those little marks. Okay? If AB is equal to, right? So this part's equal to 2/3 x plus 2. And BC is equal to 1/2 x plus 14. What is AC? So, with that being said, right, I want you to think about the geometric concepts. Okay? Think about the geometric concepts. Don't think about the numbers. Okay? I'm trying to find AC, right? So, with that being said, instead of looking at those things, let's look at this whole segment. Okay? All right, let's look at this whole segment. Okay? What do I know about this segment? There's a couple of things. Go ahead. Anything. We're not on that question. Okay? Okay? All right. I'm just going to pretend like you guys don't know what you're talking about. Okay? B is the midpoint, right? So since B is the midpoint, that means that AB is congruent to BC. Right? I'm good now. I'm just going to take control. I'm just going to do it from now on. Okay? So by definition of congruency, that means that they are equal to each other. Right? That means that AB is equal to BC. So now I can go ahead and substitute those expressions that I have. So I have 2/3 x plus 2 is equal to 1/2 x plus 14. Okay? Now, a lot of you guys are afraid of fractions, especially when one has to deal with thirds and the other has to deal with halves, right? There's an easy way to get rid of fractions, and you always want to look at the denominator of both sides. Okay? The denominator of the left side is 3, and the denominator of the right side is 2. You want to look for a number that 3 and 2 both go in, and you want to use the smallest number. And that number should be 6, right? So with that being said, in order to get rid of the fractions, and you don't have to do this, right? But it does get rid of the fractions right away. I'm going to take the left side of the expression and multiply it by 6. And then I'm going to take the right side of the expression and multiply it by 6. Notice that I'm doing it on both sides, right? And I am doing this solely with the purpose of getting rid of my fractions, okay? Notice that I'm doing it on the left side and I'm doing it on the right side. I'm doing that to keep my equation balanced, right? If I were to use 6 on one side and 4 on the other side, my equation would become unbalanced and it would be an untrue equation, okay? As long as I do it to both sides, it's A-okay. Now, Look what happens when I use the 6. 6 times 2/3 is 2x. Wait a minute, 4x. All right. 6 times 2 is 12. 12 divided by 3 is 4. So that's 4x. Then 6 times 2 is 12. Look at that. The fraction went away. I get 4x plus 12 equals. Distribute this 6. 6 times 1/2 is 3, so that's 3x. 6 times 14. 6 times 14 is, let me see, 24, 84. Okay? From here, it's simple. There's no more fractions, right? It's just whole numbers. Okay? From here, you can subtract 3x, and you get x equals. Subtract 12, and you get 72. So now I know x is 72, but that's not the answer, right? Okay? That's just x. The question's asking for AC, so it's asking for the whole entire segment. Okay? Now, my personal opinion, since 72 is an even number, right? Instead of putting it in the 2/3 expression, I'm going to put it in the 1/2 expression. Okay? So 1/2 of 72 plus 14. 1/2 of 72 is 36. 36 plus 14 is 50. Now, why is that important? That tells me that BC is equal to 50. Well, guess what we said earlier? We said that AB and BC were equal to each other, right? We said that. So since BC is 50, that means AB is also 50, which means AC is 100. Right? See how it's easy to get rid of those fractions? Do you have to do that with the fractions? Absolutely not. Okay? You can subtract the fractions and do mixed fractions or improper fractions. Completely up to you. But to me, this is the easiest way to do it. Okay? And when you go to algebra 2, you might deal with what they call matrices, and this will be an easier concept for you to grasp when you go to that part. Okay, so number 4. It says point U is on TB. So I'm going to go ahead. Does it say it's in the midpoint? No. So point U is on TB. So it can be anywhere, right? I'm just going to put it there. Okay, and it says B is on UE. It says that UB is 3 times as long as BE. Okay, again, when we draw this, it's not for accuracy, right? It's just to see representation, right? So it might not look the way that it says it on the problem, and that's okay. All right, so let's see this. It says UB is 3 times as long as BE. Is it telling me what BE is? So therefore, that means that BE is my unknown. So that means BE is X. But it is telling me that UB is 3 times as long as that, right? So that means that UB is 3X because that means 3 times longer, right? And TU is 4 times as long as UB. So that's going to be, and just bear with me, you guys might say 12X, and that's okay, but I'm going to do 4 times 3X just as a representation, right? Because UB is 3X, okay? TU is 4 times that, 4 times 3X. Or in other words, obviously 12X, right? Okay, so last but not least, it says TE, the whole entire segment, is equal to 48. Okay? We can do our segment addition postulate by saying TU plus UB plus BE equals TE, right? Add up all those segments, it equals the whole entire segment, right? So I'm going to go ahead and write this algebraic equation. 12x plus 3x plus x equals 48. I got this 12x by saying 4 times 3x. Okay? Combine all my x's and I get 16x equals 48. Divide by 16, x equals 3. Okay? That's not what the question's asking for. It's saying how long is TB? So plug 3 back in. If I plug 3 back in, that gives this 36, and that gives this 9. So 36 plus 9 equals 45. So TB equals 45. Cool beans? Okay. 12 through 16, it says to use the figure. Okay. On number 12, it says name a pair of vertical angles. Okay. I'm going to give that to you. Angle 1 and angle 2. Now, the relationship with angle 1 and 2 is really important. Okay. Angle 1 and angle 2 are vertical angles. Vertical angles happen to be congruent. So, for instance, if I said that this was 100 degrees, then this angle down here would also be 100 degrees. Right? That is important. Okay. Number 13 says name a pair of linear pair angles. Well, linear pair angles are supplementary adjacent angles. Adjacent means they share the same ray, right? Next to. So a pair of linear pair angles, and there are a lot on this, but I'm just going to give it to you. Angles 1 and angle 3. Now, angle 1 and angle 3 are not congruent. They are not congruent in this situation. They could be, but technically here they're not, right? In this picture. What's important about this relationship for number 13 is that they are supplementary, which means that angle 1 plus angle 3 equal 180 degrees. Okay? That's the important part to know about linear pair. Okay? For vertical angles, the relationship is that they're congruent. So that means that angle 1 equals angle 2, right? You see the different type of relationship those two have? Okay? Vertical equal / congruent. Okay? Linear pair, supplementary and adjacent / add up to 180. Okay? So, with that being said, we're using this same picture above to answer number 14. It says if the measure of angle 1 is 132 degrees, then what is the measure of angle 2, angle 3, and angle 4? Well, we just got finished saying angle 1 and 2 are what? They're the same. They're vertical angles, right? Right here it says angle 1 is congruent to angle 2, right? So therefore, that means that angle 2 is also 132 degrees. Okay? So we found out angle 2. Angle 3, angle 1 and angle 3, we just said that relationship there, right? Okay? So 132 plus angle 3 equals 180. Subtract 132, and we get angle 3 is equal to, what is that, 48? And then last but not least, we're looking for angle 4. Well, guess what? Angle 3 and angle 4 are what? Because they're vertical angles, right? So angle 4 is also equal to 48 degrees. See those relationships? That's important to know. Okay? All right. Now we're going to use the exact same stuff, except now we're talking about expressions. Okay? Here it says the measure of angle 1 equals 6x minus 2. So now we're going to use some different expressions. Instead of doing numbers, it's just an expression. So this is 6x minus 2. The measure of angle 2 is 3x plus 7. So what's the relationship with angle 1 and angle 2? Good, they're vertical angles, so therefore they're congruent. Congruent means they're equal, right? So angle 1 equals angle 2, just like we said here earlier. Okay, so 6x minus 2 is equal to 3x plus 7. X equals 3. Okay, if x equals 3, right, we can find angle 3 by plugging it in here. 6 times 3 is 18. 18 minus 2 is So this is 16 degrees. Angle 1, 16 degrees. Again, this is not for accuracy. This is just for representation, right? If angle 1 is 16 degrees, what's the relationship with angle 1 and angle 3? What's the relationship with angle 1 and angle 3? They're a linear pair. They're supplementary. So that means angle 1 plus angle 3 equals 180, right? So in other words, 16 degrees plus angle 3 equals 180, right? Subtract the 16 to both sides, and we get angle 3 equals 164. Okay? Again, we're using that picture for representation, okay? All right. I'm going to go ahead and skip around. I just want to make sure I hit this conditional statements because we didn't spend a lot of time on conditional statements, okay? So I want to make sure I hit this before you leave class today, okay? The statement is fish have scales. Write a conditional statement for the given truth, then write the others also. So the answer key is very basic, okay? I'm going to go a little bit more in depth, okay? So for conditional statements, fish have scales. I'm going to write this as a conditional statement. If an animal has scale, or sorry, if an animal is a fish, then it has scales. And whenever we do conditional statements, this is saying if P, then Q, where P and Q are my hypothesis and conclusion. So if an animal is a fish, so animals of fish is my hypothesis, then it has scales is my conclusion. Right? Okay, that's my original conditional statement. Okay, now I'm going to go ahead and I'm going to write the converse. The converse switches up your statement and it switches the conclusion and the hypothesis. So, in other words, your converse is if Q, then P. Notice that it's switching them, right? And you want to make this to make logical sense. We don't want to say if fish, then scales, right? Let's make logical sense, right? So we switch it if the animal has scales, right? Scales. Then it is a fish. Notice right here that all we did was switch. My hypothesis is now in the front. I'm sorry, my conclusion is now in the front, and my hypothesis is now in the back. Now we do the inverse. When we do the inverse, that always goes back to the original conditional statement. The inverse is the negation of the statement. It negates both the hypothesis and the conclusion. So, in other words, it's if not P, then not Q. All right? There's no switching, it's just a negation. So, sometimes we'll use the word not, sometimes we'll use the implicit opposite word, i.e., love hate, right? I.e., happy, angry. Yeah? Okay. So for this particular purpose, we're going to say not. So we're going back to the original conditional statement. If an animal is a fish, so therefore, if an animal is not a fish. So if an animal is not a fish, then it does not have scales. It doesn't have scales. And you notice here I'm trying to make emphasis on the negations, right? Because that's what the inverse does. Okay, because the inverse is all about the negations. Okay. Last but not least, we have what we call the contrapositive. Now, the contrapositive does both the inverse and the converse. Okay, it's the combination of both of them. Okay. So, okay. All right. So your contrapositive, the easiest way for me, and this is just a personal preference, you don't have to do this, but the easiest way for me to get the contrapositive is instead of going back to the original conditional statement, I like to go to the converse because the converse is already switched, right? The contrapositive has to switch and negate. Well, since the converse is already switched, all I need to do is the negation of the converse, right? So, in other words, that one's going to say if not Q, then not P. Okay, so if the animal doesn't have scales, right? Then it's not a fish. Again, switching your hypothesis and your conclusion and the negation. Okay, and then let me go ahead and underline the negations. Oh, God. Of course, I would mess that up. Okay. All right. We have some keywords here. Know your vocabulary. I think we had a vocab quiz soon. So know your vocabulary. Know the difference between a line and a line segment. Okay. Collinear, coplanar, congruence, all of these words. So collinear and coplanar are very similar to each other. Okay. Collinear means together on the same line. Coplanar means together on the same plane. Okay. All right. Know what complementary means. Complementary means that angles add up to 90 degrees. Supplementary means that angles add up to 180 degrees. Know your types of angles, vertical angles and linear pair. Know their relationship. Know how to do the converse, inverse, and contrapositive of a conditional statement. Know that a conditional statement is an if-then statement. The if is not part of the hypothesis. The if indicates where the hypothesis goes. The then tells you where the conclusion goes. Okay, so be very careful with that. Know what congruent is, and then check the answer keys. Right, the answer key is on Schoology as well, and I will be posting this video as well too. Okay.